All right, so this is a 2 by 2. Again, we're going to do the same kind of thing, where we're going to use the exact same matrices, except for this first one, we're going to do A times B, and for the next time we do this, we're going to do B times A. But again, I can't put them all on the same slide, so we're going to have to just do it in 2 slides. All right, so let's do this. So this is a 2 by 2 matrix. This is also a 2 by 2 matrix. So now you can see, regardless of which order we put them in, if they're all 2 by 2 matrices, they're going to be able to be put together, right? So if I have this 2 by 2 matrix for the A and the 2 by 2 matrix for the B, those insides match, what's the dimensions of my new matrix? Yeah, it's also going to be a 2 by 2. 2 by 2s all around, right? All right, so with this 2 by 2 matrix, now we're going to do the exact same thing that we did before. Grab this top row, bring it over here, and distribute it to this first column. So the 1 is the first term here, goes with the negative 2. The 3, which is the first term here, goes with the 0. So for this one, I have 1 times negative 2 plus 3 times 0. Top left, top left. I'm going to go with the top right. So I'm going to take my top row here. I'm going to distribute it over here to the second column and then write those up. I'm going to have 1 times 7 plus 3 times 2 because we're taking that distribution here. Now go to the second row and we're going to do the exact same thing. Take this row and multiply it times each column. So I have negative 2 times negative 2 plus 5 times 0 and negative 2 times 7 plus 5 times 2. And you can always check yourself because notice these match up, negative 2's and 0's, 7's and 2's because those are the columns that go with it. A negative 2, 5, negative 2, 5, 1, 3, 1, 3 because those are the rows that go with it. So you've got that checks and balances associated with it too when you write out all your steps. If you go through and try to skip steps, then you won't have that additional check and balance that you have got going for you with this. All right, so this is now negative 2 plus 0. So if I'm going to write my answer, it's negative 2. 7 plus 6 is going to be a 13. 4 plus 0 is 4. And negative 14 plus 10 is a negative 4. So really, your final answer is nice and small. It's just that medium setup stage where you have the big blanks that you're filling in. Good. Let's do B times A and see how that differs. Okay, with this B times A, now when you go to set this up, I like to rewrite it in the order that I'm given because remember these are not commutative and my feeble little brain, it can't switch that stuff back and forth. So if I'm given this A times B, I'm actually going to write out my B first of negative 2, 7, 0, 2 times my A matrix here, which is going to end up being 1, 3, negative 2, 5. So if I've got them set up, it's a whole lot easier for me to go through and say, all right, with this 2 by 2 matrix and this 2 by 2 matrix, when I go to set up my newbie, I can identify what my rows and columns are much easier. So if I get this top row, distribute it to each column, then I end up with negative 2 times 1 plus 7 times a negative 2. And if I distribute it to the second, I get negative 2 times 3 plus 7 times 5. And on the bottom, I can distribute. I have 0 times 1 plus 2 times negative 2. And 0 times 3 plus 2 times 5. All I'm doing here, the exact same thing is happening. I'm taking this column, turning it on its side and matching it up. Negative 2 times 1 and 7 times negative 2. Negative 2 times 1, 7 times negative 2. You're just putting it on its side. 0 times 2, so the 0 goes with the 1, 2 goes with the negative 2. 0 goes with the 3, 2 goes with the 5. Just line them up. All right. So then we get our answer out of this. And we have a negative 2 minus 14. So I get a negative 16. And a negative 6 plus 35. Oh, what is that? A positive 29. A 0 minus 4 is a negative 4. And a 0 plus 10 is a positive 10. So this is our answer if we have B times A. Now what again did we get when we had A times B? So when we had A times B, we got negative 2, 13, 4, and negative 4. Are those equivalent? No, not even a little bit, right? So that's what makes a difference. Yes, you can, if the dimensions match up, multiply A times B and B times A. That's legit. As long as the dimensions match up, but that does not and will not mean that you have exactly the same answers. So if that happens, you do have to multiply that out to get your answers. All right, guys, enjoy the homework. These matrix are a great way to end the semester, I think, because they're so much fun. So enjoy.